Okay, today is October 6th, and this is a review of what we went over today. And we took a look at rational numbers, and this is going to be really focused on what you're going to be covering in your assignment today. So it's not comprehensive. We're just going to focus in on what we expect out of the homework, and then we can move on from there. So if you have any questions, feel free to post on the Google Classroom site, and I do read those. So let's go ahead and get started. So we already looked at rational numbers. Okay, and we broke that down kind of looking at the root being ratio. And one of the things that we kind of mentioned is a ratio looking like this, and we've used this for a long time. And we've got a ratio here of 4 to 1. Now 4 to 1 can really be anything. It could be 4 apples to 1 orange. It could, it's kind of a plug and play. Fill in here, and so that's what it looks like. And then later on, you may have written it something like this, which, by the way, looks a lot like a fraction. Or if you want to write it a little more clear, you can actually write it as a fraction, as 4 over 1. So a ratio is really talking about numbers that can be written as a fraction, and that's the vocab that we wrote down earlier today. So hopefully you've got that in your notes, but that will be on the quiz on Thursday, so remember that. But so rational numbers, the root word being ratio, and if you show a ratio, we have 4 to 1, again 4 to 1, and then as a fraction 4 to 1. So any rational number, of course, is again just any number that can be written as a fraction. And one of the other things we're going to be dealing with today is moving beyond the fractions and moving those rational numbers back and forth between a mixed number, a fraction, and a decimal. And there are a couple of different kinds of decimals that we'll work with today. One of them is a terminating decimal. Okay, and a terminating decimal is really just what it sounds like. It's just a decimal that terminates, or it doesn't go on and on. So a terminating decimal could look like this. Okay, or you can have one that is not even that long. You can just put 0.6. Okay, it terminates, it doesn't go on. Or even if you looked at, let's look at a fraction, and if we said 3/5, which if we convert that to a decimal, that becomes 0.6, but it stops right there, so that's actually a terminating decimal as well. Okay, example of one that is not a terminating decimal, let's look at that and see what that looks like. How about 5 over 6? Okay, if we convert that over into a decimal, you end up getting 0.83, and the 3's keep going on, and so I'm going to put the little bar over it showing that. Okay, so that one keeps going on, so this is an example that is not, okay, I'll cross it out there, that's not a terminating decimal. Okay, that's an example of what we call a repeating decimal. So let's get into that. So here's your second kind. Okay, and let me move the screen up for you a little bit. We'll stop at terminating there. So let's look at a couple repeating decimals. So we already said that we knew, let me get back to the pen here, we knew that 5 over 6, if you divide that out, you get 0.8333, and in the textbooks you'll see this. They'll put a lot of periods after there, and that just indicates that those 3's are going to keep going, which is why it's so much easier just to write it as 0.83, and then over the 3 we know that that's the one that's repeating, and so that's where we put our line indicating that's a repeating decimal. So that's one example of it. So you may also realize that we've kind of covered a few different ones. You also may find one that is like 0.4, and then it goes 1 2 1 1 2 1 1 2 1, and that's also a form of a repeating decimal. But here we got to be careful where we put the bar over the top, because if we shorten that up, it's 4, and then it's the 1, 2, 1 over here that repeats itself over and over. So we put 1, 2, 1, and that's the only part that we can put the bar over. So remember, don't put the bar over anything except for the actual repeating part. And it could be one number repeating or several numbers repeating. Okay, so let's go into some of the things that you're doing in the homework today. So a couple of things is you're changing fractions into decimals, then you're also changing decimals into fractions, and on top of that we've got mixed numbers. And so I'll show you an example of each one of these, and these are pretty brief, and so they're not comprehensive at all, but they should be enough to help. Okay, so on the first one, let's go ahead and we'll go from fraction to decimal. Okay, and we'll go back to red here. So the one that we went over in class was 1/2. And I use 1/2 because most people will look at that and obviously know that it's 0.5 as a decimal. So we know that this is equal to 0.5. And you can do that either by looking at it, knowing what 1/2 is, or you can actually go through, and the process is to take the numerator, the top number, and divide it by the denominator, so the bottom number, and that's going to give you that 0.5. So 1 divided by 2 will give you the 0.5. And I showed you this yesterday too, but I'm actually going to show you how to convert that back into a fraction. So we'll do kind of two examples in one here. So what you're going to look at is off here to the right. Let me write an example down, and I'm just going to put 1, 2, 1. Okay, simple enough. And as we look at that 1, 2, 1, the 1 is in the tens place. The 2 is in the hundredths place, and this one is in the thousandths place. And how that helps us is because if we know how long our decimal is, then we can convert it and look at what our base is going to be. And let me show you over here. So we have 0.5, and that 0.5, let's switch back to red here, is in the tens place. So that 10 becomes our denominator, and then we just put the 5 on top. So that's how we got the 5/10. And you may look at it and say, well, 5/10 is not 1/2, and that's because we haven't simplified it yet. So when you use this method, you're going to realize that you end up having to do a lot of simplification to get the answer on this. So 5 divided by itself is just 1, and then 10 divided by 5 is 2, and so that's when you get the complete conversion back to the original fraction. So that's what we're going to do, and let me put another example of just a decimal. So let's look at another decimal. And the decimal we'll look at, let's look at 0.45. Okay, so on this one we're actually going to go from a decimal to a fraction, so we'll go backwards to what it says up the top. So we know that the 4 right here, okay, that's in the 10 spot, and the 5 here is in the 100 spot. So we're going to put 100 as our denominator, and then that way we can just put the 45 on top. So 0.45 as a decimal is equal to 45 over 100. Now again, that's not simplified, and so you have to simplify it. And if I look at it, I say I know that 5 is going to go into both of those, and so 45 divided by 5 will give you 9, and 100 divided by 5 will give you 20. And so this is the simplified fraction of converting that decimal, or that decimal into the fraction. Okay, I'm going to move up because there's one that I haven't covered yet, and that's the mixed numbers. So let's get this out of your way. Okay, and let's go back to a mixed number. So let's go to, this is one that's actually in your homework, so if you listen to this you can get a free answer. I won't tell you what question it is, but you'll be able to look pretty quickly. So let's look at 1 and 1.56. So we're wanting to take this into the decimal form. And to do that, we've got a mixed number over here, so 1.56. So we need to make that back into a full fraction, or rather an improper fraction. And if you remember from the past, to do that, you take this number and multiply it by the whole number, and then you take that answer and add it to the top. So 6 times 1 is 6, and then plus 5 gives us 11, and then we keep the same denominator. Okay, so now we're at 11.6. So now we have just the fraction there, and we can go ahead and convert that. So remember, all we're doing is taking, I'll change colors here again, is taking the top and dividing that by the bottom, and that's going to give us, in this case, 1.8, and then we have a 3 that repeats. Okay, so we've got a couple different sections on this one. So we had the original, we had the original mixed number over here, and to make that easier, we just changed it into a fraction only, so we weren't worrying about the whole number at this point. And then we just changed that fraction into a decimal. Okay, so you're going to see something like that. Okay, and then there is one last one that the homework's going to ask you to do, so I'll just show you a quick example of that. That's also a review. But it'll ask you, and in this case, let's put one up here. Let's say a negative 2.2, and then it leaves kind of a space in between them, and then they have a negative 2.42, and so yep, this is one of your homework questions also. And what they're asking you for is fill in, either a greater than, or a less than, or equal to, or so on. So when you do a problem like that, to fill that in, remember the number line, because if you get caught up on which one's negative, it'll look different than if one of those is positive, and I'll show you why here. So we'll do a quick number line, and we won't do a very detailed one. So 0, 1, 2, and we'll go out 3. And then we have negative 1, negative 2, and right at the end there we'll sneak in a negative 3. Okay, so let's switch colors, and let's make the first one blue. And so it's a negative 2.2, so we're actually going over here 2, and then I'm going to estimate that it's right about there. Okay, so that's the blue one. So that's the negative 2.2. And let's look at this one as orange. So this is a negative 2.42. So we go negative 2, and then we're a little bit further on that one, almost halfway. So we're going to say this one right about there somewhere, and that's the negative 2.42. And it's going to ask you, is it greater than, less than, or equal to? Well, in this case, the farther you go left, remember that, the number is less. And the farther you go right, the number is more or bigger. So if we look at this, it's the one that's closer to 0 that's going to be the bigger one. So 2.2 is the bigger one. So the appropriate symbol is greater than. So a negative 2.2 is greater than a negative 2.42. Okay, so hopefully that helped you out for your homework today. If you have any comments, please leave those. This will be posted on your Google Classroom. And because these are new, if you have comments or questions, or if you want to see something to make it clear, go ahead and put those comments in there. I do read them, and if I can, I'll make that change to make these better videos for you. Okay, have a good night, and we'll see you Wednesday.